Okay, good. So first of all, a little bit about me. So my background is statistical genetics. I did over 10 years of scientific research. Most of it was in Oxford, a bit in Cambridge. And since then, for the last 5 years, I've been creating and running data science teams in 2 startups in London. Qubit was the first, and the second is Skimlinks, where I am now. And the data products that I've developed and designed are in use at lots of very large e-commerce companies and publishing companies. And I'm also really active in the community. So I run 2 meetup groups with around 7,000 members in London. Maybe some of you guys have been along to some of them. I also run a small networking group for senior data scientists. It's an invite-only private networking group. So I get to talk to lots of data scientists. And in the last couple of years, I've been hearing the same kind of stories happen. I've been hearing about the same stories happening again and again. And one of them is that I've heard that what happens very frequently is that a data science team is formed, everyone's hired, the team's hired, the project starts, and then around a year after that point, everything's declared to be a failure, and the team either quits or they're sacked. And then the company either decides, okay, we're going to start again from scratch. We're going to build a new data science team because we screwed up on hiring the first guys, or they just decide, well, this data science thing is just not for us. We don't want to do this data science stuff anymore because it's not working. So I got to thinking, well, why is this going on? So this seems to be a symptom of something weird happening in the industry. So for the last year, I've been interviewing people in the community, so people in my meetup groups, in my networking groups, senior data scientists, to try and figure out what are the failure modes of data science projects. And I'm talking about data science R&D projects. What goes wrong and how can we fix the problems? So let's start with number 1. So this is one of the most frequent things that I've heard from so many people. They started the project and the data just wasn't ready. And the previous speakers spoke very well about this. You really need to spend a lot of time to make sure the data is clean and well structured before you even begin. Don't make this mistake of thinking the first sentence is correct. And a very wise data science consultant said to me, really, if the data's never been used in a project before, he just assumes it's garbage. And he says he normally adds around 6 months onto the schedule because he knows it's going to take at least that long to get the data into a reasonable state. So the fix for this, I think, is to do a data audit, unless the data's already been used in a data project. I think that's really good advice. So the second reason is that someone once in some kind of meeting said this thing. The company had loads of data, it's been collecting data for years, didn't really know what to do with it, and knows it's got loads of it. Data's the new oil, right? So it must be valuable, we must be able to use it for something. Typically the story goes that the company hires 12 people. I heard they hired a team of 12 people, Hadoop specialists and data scientists for this big project, thinking that the first stage is going to last around 12 months. So I spoke to someone who they said that after 9 months, the 9-month point was when they first started to think, well, who's actually going to buy this data once we've done all of our Hadoop and big data stuff to it? Who's the customer going to be? How are they going to use the data? And how are we going to get the data to them? And normally what happens is, an answer to the first question is, there is no customer. Well, and we don't know who's going to buy it. The project gets canned, everyone gets sacked, or they quit. I've heard this story. I almost didn't put this one in there because it's just such an obvious thing, but I've heard this story so many times I had to put it in. The third thing is the data scientists really need to have the right tools and data to do their jobs. So this is from a data scientist. She sent me this email 6 weeks after she started in a big company as the first senior data science hire. She's been complaining for about 6 weeks that she couldn't install Python and R. She wasn't given permission to install Python and R. She's really sick of it. She's quite pleased in this email because she's finally got permission to install Python and R. This is 6 weeks after joining. And then she sent me this 5 minutes later. Not a happy person. And I hear this story very, very often as well. So I want to introduce you to this guy. This is a product manager at a very well-known online auction house, who you definitely will have heard of. had to protect his anonymity, so I've kind of pixelated his face. He told me about a story that happened with an A/B test. So for the main e-commerce search engine on the site, they had a new algorithm, or a new prototype of an algorithm that they thought should work better than the original search engine. So they did an A/B test, did the right thing. And they found that the prototype algorithm worked a lot better than the original algorithm, delivered more conversions, was more effective. So they made the decision, let's put it into production, which is a big job. It's a very, very large company. They decided to move ahead and put it into production. It was only after they did this that they realized that there was a bug in the original A/B testing code that meant that in the original test, they hadn't been testing the new algorithm. They'd just been testing the old algorithm against the old algorithm. So all of the results were just complete nonsense. And this happened, I think, because of the fourth reason, which is they didn't have a data science leader. So they just didn't know the results were rubbish. They did what they thought was the right things to do in an A/B test, but they didn't know about these things. I really think you need people who live and breathe this stuff. Selection bias, measurement bias, the classic scientific and statistical principles need to be really at the heart of what you're trying to do. If you're trying to do data science R&D, because it's hard. Oh, and by the way, if you see this on a LinkedIn page for someone, that means they're not a data scientist, they're a BI professional. This is what a data scientist looks like. That leads me to the fifth reason, which is that you don't always need data scientists. And I often hear that we hired loads of data scientists, but actually we didn't really need them. We just thought it sounded like everyone else had data scientists, so we thought we should get them. If you're doing ETL, if you're just taking data, filtering it, aggregating it, preparing it for upload into a database, you don't need data scientists. You need data engineers. The same goes if you need reporting, dashboards, and so on. You need BI analysts. These are important skills, important roles with their own skill sets. It doesn't really do anyone any favors by trying to rebrand them as data scientists. So there's so much hype now about machine learning. There's so many blog posts. Like every day, there's a new blog post about machine learning. People are reading about this stuff. What has happened is that people have read so much about these things. They know the buzzwords. They've heard of things like ensembles and regularization, cross-validation. They start to use these terms, and they start to think that machine learning is easy, and it's not. The problem is that machine learning really is easy when you've got like a nice, clean data set, but we never have a nice, clean data set. And someone told me that an example of this, they work for a national newspaper in the UK, and they said that their boss said, what we need to do is predict how many people are going to subscribe next month. We've got all of this data, we should be able to do it. We've got big data, we should be able to do this, right? So let's take the previous month's worth of data on the user's behavior online. So if the user has been interacting a lot with the website, they're probably going to subscribe. So you should be able to make some kind of machine learning model. It should be simple. The problem was that most people on this site, when they subscribe within 3 days of first going to the site. So the previous month's data is completely useless for predicting what's going to happen next month. You only have a three-day window of usable data. And what I'm trying to say here is that the data may not contain the information that you need it to. So this may sound like a standard machine learning problem, should be easy to predict, but very often the data just does not contain the information that you need. So now I want to talk about asthma. Can I ask who's got asthma in the room? I've got asthma. I'll put my hand up. That seems like a very low proportion, because the proportion of people who have asthma in the UK is about 10%. So why do I want to talk about this? So I want to talk about a study that happened in the States where the aim of the project was to create an automated triage system for people who came to a hospital with pneumonia. So many people who come to hospital with pneumonia, they don't need anything special. They're very unlikely to have any complications or to die. So they're just sent home with some antibiotics. The system aimed to predict who those people were going to be so that they could be sent home with some antibiotics and not clog up the hospital system. Whereas only really concentrate the aggressive treatment on those people who had a high chance of death. The problem was that the system wanted to send home everyone who came with pneumonia who also had asthma, which is weird because people who have asthma have a very high rate of death if they get pneumonia. And it turned out that what was going on was that in the original data set, hospitals have a rule that if a person comes to hospital with pneumonia and they have asthma, they're immediately put into intensive care. So these people had very aggressive treatment and they very rarely died. So in the training set, there were no examples of people with asthma dying with pneumonia. They had the aggressive treatment and it worked. So this meant that the system was never deployed because it gave nonsense results. And it was a neural net that was used. One of the problems with methods like neural nets is that they're very difficult to interpret. Fortunately, in the end, a student who used a far simpler method figured out that the system had been learning this mistaken assumption that asthma meant that you're never going to die from pneumonia. So my advice there is to always use an interpretable model. And if you do need to use a complex model, and sometimes you do need to, always test against a simpler baseline. So at the core of science is reproducibility. You need to be able to reproduce your results. You do all of these things, you'll be able to do that. I won't say any more about that. This is another one that comes up a lot, which is that the company thinks it wants to create a data science R&D team, but really is the culture of a scientific R&D team really going to work in your company? And it's a question that's a very difficult one to answer, but what often happens is that experts for instance, just prefer gut instinct. They don't really want to look at the data. And there's actually a psychological phenomenon that's quite well known that experts often don't want to see real data. They prefer to use their own intuition. They trust their own intuition. They actually feel quite threatened by data. This happens quite a lot. The other thing is that R&D is inherently a very high-risk activity. It's a very high rate of failure and very difficult to predict how long something is going to take. And you need unusually high levels of persistence in order to succeed in an R&D project. Yeah, you also need to do all of these other things, lab meetings, give talks, publish papers. You need to do these. These are table stakes for doing applied science. Is your culture really going to be accepting of all of these different things? It's a question worth asking. So that's the 9th reason. The 10th reason. So this is something I see a lot. A graphic designer and a product manager get together, they make a wireframe, they think about UX, they have several user interaction sessions, they figure out what the data product's going to look like. And then in the end, this can be months down the line, 6 months down the line, they then start to use real data. And they start to see what real data looks like in their fancy UX. The problem is that when you put real data into a predefined UX, what you often find is that there are weird outliers, the distribution is really strange, the data is really undynamic or really boring, just doesn't show you anything interesting, or it's too predictable, or it's not predictable enough. It's impossible to predict this without real data. This is as close as I get to laying down a rule, but I think UX and wireframe should never, ever be designed without access to real data, or you'll end up in bitterness and disappointment, just like this leopard weasel thing, whatever it is, I'm not sure what it is. So that's all I have to say now, but the project is still alive. I'm very, very open to other people's opinions. If you think I've got any of this wrong or I've missed an important reason, please get in touch. I'll put the slides on my website. And if you have, I'm going to put a survey there actually, so that if anyone has any additional anecdotes or anything they want to talk about, then they can get in touch and add their data to this. I want to expand this to have as many stories in there as possible. So that's where I end. Thank you. questions?
Martin,
Hello.
you've given this example of 10 reasons why a project doesn't succeed. Would you say then that if we do the opposite of all of those 10, the project will succeed?
So the question is, if we take all of my advice with these 10 things, don't do any of these bad things, will the project definitely succeed? The answer is no. The R&D, scientific R&D, is inherently risky. And really what I'm trying to convey in all of these slides is that there is a very high risk of failure for real data science R&D. And that's the biggest failing is not understanding that from the outset, I believe. Question at the back.
Thank you. Where do you draw the line between doing science, data science, and just doing reporting, complex reporting?
Yeah.
So
I think science is about trying to find some underlying principle. You're trying to find something, you're not trying to find out a fact about the data that you've observed. You're trying to use that data to infer something else. For instance, you might be trying to make predictions about the future. That's at the heart of science. I think reporting is about observing data, taking some statistics, and describing the data that you see. If you want something underlying that, then you need to use scientific principles.
Hi, thank you very much. So I'm not a data scientist, and I recognize some of the things that you've outlined in your 10 reasons why projects can fail from a kind of business perspective, if you like. But in your experience, what do data scientists, I don't want to say do differently or learn or weaknesses, but what are some of the things that you see data scientists do that don't work in the real world, inverted commas?
So one thing that I've heard, and I've heard this while I've been surveying people have said things like, our business people, they're just not technical enough. They don't understand our complex models. And I sort of write it down, but I'm thinking, well, that's your problem. They don't need to understand these complex things. You should be conveying what business value there is in what you're doing, and it doesn't really matter what models you're using as far as the business is concerned. So that's one of the things they definitely do. And I also think, to go back, if I can, the back button doesn't seem to be working. Doesn't matter. I talk about using a simple baseline comparison, and I kind of, I don't make a big deal of that, but actually that's a really, really important point, because what I've often heard, especially from the business side, is that the data scientists will say, they'll just say the standard models don't really work for this problem. We need to create our own super complex model, in Julia or something. That's fine. If your data scientists think that's the right thing to do, that's fine. But they need to test that against a simple baseline model, and that often doesn't happen. I think if you say, okay, well, show us what this simple model looks like, what the results look like, and then at least we have something to compare it to, the data scientists will tend not to go down such a deep rabbit hole and waste time. Question over here.
Hi there. We've delivered, as a company, a few data intelligence or business intelligence products that are data-driven, such as this geo-specific data, etc. As yet, I haven't worked with a data scientist. We're usually working with product owners, doing the typical UX activities, trying to user-centric design, etc. For a company such as us, who is used to delivering these sort of products but hasn't worked yet, what would be a typical entry point to working with a data scientist in a simple way, rather than trying to bite off more than we can chew in the first instance and build up from there, in your opinion?
Sorry, rather than doing what?
Rather than trying to go all in with a data scientist, a team of data scientists or so on. You mentioned about having a data scientist leader. What would be a good way to bring a data science within a team as a starting point?
Yeah, talk to a consultant. I think that very often a company just builds a data science team from scratch. But really, if they'd spent a couple of weeks with a consultant And the consultant could have said, this is a good plan for you. This is what the data looks like. I've had a look at some real data, and I think you're really 6 months away before you can really start using this data. You need to do a lot of cleaning of the data, and you need to invest in whatever ETL or Mechanical Turk or whatever it is or expert curation to prepare the data. Go away for 6 months, prepare the data, and then start with the team, I think is a reasonable thing to do. One more question over there.
Thank you. So you described sort of a whole life cycle of a data science project and how to approach it from the point of view of how to organize a team and, when not to hire a team like that, etc. But from my experience, quite often we talk to clients that come up with a question, but where do we get the data from? So it's like in the scenario when you were talking about the oil. So someone at the top heard that, we got to start using data science, big data, whatever, one of those buzzwords. And then it's been put on middle managers in a company, and they start looking around for where to get the data from. So the usual approach is like you described, that they come up with wireframes and then looking for data. But like from the point on the timeline, -1, where to get the data from?
Well, there's a completely different way of looking at that problem, which is to get the data first, have a look at it, and then make a decision about what you're going to do with this data. Very, very often when you have an idea in your head, so I'll give you another example that I didn't put on a slide, but a very large UK retailer of clothes, they decided to do a big data science project where they wanted to use their resale data to predict who was going to buy certain products. And they wanted to do data science, find patterns, using machine learning, find patterns in the e-commerce data to figure out how they could cross-sell products and how they could predict who's going to buy what. What they found, so they did this, they went through this whole process, they did the UX, they designed everything, then they got the data, and then when they set the product live, they realized the insight that they always got was something like, the people who are likely to buy shoes are those people who bought shoes in the past. Really boring, obvious patterns that everyone knows about, all marketers know. The problem was that they started off with their vision in their head of what the product was going to look like. But if the data scientist has just looked at the data first and just said, well, let's have a look. That's how science works, right? You look at data and you try and figure out, let's get some ideas here. What can we find out from this data? I think that's a much more powerful approach.
So essentially, this is on the business owner side, the risk in terms of having to invest in finding and getting a meaningful sample of data before actually thinking to do something with it.
I think that you really need to attack the problem from both angles. But I'm being told that the time is running out, I think. Yeah. Thank you very much.
But I think you can follow up afterwards.
Yeah, please.
Lunch break.
Come and grab me later.